Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
Did you know that almost 50%, half, of all compressed air used in industrial plants goes towards simple air blow applications? It's true. That is a massive amount of energy, literally flowing completely unseen around us right this very second. Today, we're unlocking pneumatic manifolds. Now think of them as the invisible nervous system of modern industry. They're this secret, silent force, powering manufacturing, complex automation, and honestly, making so much of our everyday lives possible. Okay, let's dive right into this. Here's our roadmap for today. 1. The hidden power grid. 2. How pneumatic manifolds work. 3. Real-world industry applications. And finally, 4. Maximizing efficiency and savings. Section 1. The hidden power grid. The secret to complex automation. You know, we so often focus on the heavy machinery and giant factories, but it's super easy to miss the complex systems running silently behind the scenes. Just look at complex robotic automation setups like car manufacturing. It looks like a ton of heavy lifting and metal-on-metal force, right? But what you might not realize is that all this incredibly precise, heavy-duty movement relies entirely on highly organized, invisible airflow. Without it, these advanced robots are practically just really expensive, heavy statues. And that brings us to the absolute core component making all of this possible, the pneumatic manifold. Think of this device as the ultimate traffic cop of the factory floor. By acting as a central connection point to distribute air or liquid from a single source out to multiple output ports, it completely eliminates chaos. It basically takes a massive continuous flow of energy and streams that fluid or air exactly where it needs to go when it needs to go there. Now, what's really interesting here is how incredibly compact this technology has actually become. You've got a multi-valve manifold block on one side and a compact control valve unit on the other. These solid bodies beautifully organize space. They take what used to be this messy, complicated tangle of separate valves, external fittings, and monitoring gauges, and combine the whole shebang into one sleek, highly efficient hub. Chapter 2. How pneumatic manifolds work, breaking down the airflow journey. So let's trace exactly how a simple burst of air navigates this intricate system. It operates as a true distribution hub. Step 1, the air inlet takes compressed air straight from the source. Moving to Step 2, the manifold splits and distributes that airflow out to multiple output ports. Step 3 is flow control. This is where valves step in to actually regulate the direction and rate based on specific signals. Step 4, pressure regulation ensures a steady delivery so different ports get varying pressures if they need them. Step 5 involves monitoring and feedback via built-in gauges for real-time adjustments. And finally, Step 6 handles the air return and exhaust of the used air. It gives us this perfect closed-loop operation. So why do engineers rely so heavily on these setups? Well, the core advantages spell it out perfectly. Space efficiency is huge. You're completely eliminating a maze of hoses. Improved organization means much easier maintenance and future expansion. But the real game changers here are energy efficiency and enhanced reliability. By drastically shortening the transmission paths, manifolds save massive amounts of energy while significantly reducing the risk of costly air leaks from long-term fatigue. Chapter 3, Real-World Industry Applications, where you encounter this technology. Let's step out of the factory schematics for a second and connect this directly to your everyday life. Take an automated food packaging line, for example. There is a very good chance that the packaged food you ate for lunch today or the bottled drink you just bought from the store was physically handled, filled, and sealed by these exact pneumatic actuators and vacuum packaging systems. The sheer adaptability of these systems is just mind-blowing. Pneumatics power the automotive industry, think air suspensions and brakes. They drive industrial automation, like those heavy robotic arms we talked about earlier. But get this, they also handle incredibly delicate, literal, life-saving tasks in the medical and pharmaceutical fields, perfectly regulating gas distribution in ventilators and anesthesia systems. Add in food and beverage packaging, plus HVAC refrigerant management, and you quickly realize manifolds are practically running the modern world. Chapter 4, Maximizing Efficiency and Savings, the Green Revolution in Pneumatics. We've seen how essential this tech is, right? But there is a catch. Compressed air is notoriously energy intensive. Fortunately, there is a modern green revolution happening in pneumatics right now to solve this exact issue. Meet the technology changing the game, the Parker Air Saver Unit. It is an incredibly innovative piece of switching valve technology. Instead of a continuous, wasteful blast of air, it converts it into a highly efficient pulse blow. And the absolute best part for these massive plants, it drastically improves blow efficiency without requiring a single change to the factory's existing programs or construction. You literally just plug it in and the savings begin. And this brilliantly illustrates just how impactful that simple upgrade actually is. For a typical setup using 100 units running for an 8-hour shift, power consumption is chopped exactly in half, from over 53,000 kilowatts a month down to 26,800. The CO2 discharge plummets from 17 tons to just 8.5 tons, and the operational costs, they fall right in line, cut by a clean 50%. So the crucial point is this: almost 43,000 euros. That is the estimated annual financial savings for just that one 100-unit setup. When you allow that massive economic impact to really sink in and combine it with halving the operation's carbon footprint, it's incredibly easy to see why optimizing industrial fluid dynamics is such a massive priority for engineers today. It really changes how you look at the everyday products around you, doesn't it? I'll leave you with this final thought. The next time you buy a car, grab a packaged snack, or even just enjoy the air conditioning in a large building, will you think of the invisible, highly efficient world of compressed air that built it?
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.